All right, good evening, everybody. Thanks for your patience while I dealt with some screen sharing issues. I'd like to welcome you tonight to Science Off Tap, Mangroves on the Move. I'm Sadie Mills, and I'm with the Thompson Earth Systems Institute, and I'm going to turn it over to Chelsea to tell more about our partners.
Hi, everyone. And my name is Chelsea, and I'm with the Florida Museum of Natural History. And I wanted to introduce all of you to our program, but also to our sponsors, Cypress and Grove and First Magnitude Brewing Company. These are two of our favorite breweries here in Gainesville. And when we are doing these programs in person, our favorite places to host them. So we just like to give them a shout out at the beginning of this program and remind all of you that if you're picking up any beverages for your next Science Off Tap or any other at-home events, those are two of our favorites here in town that support the museum a lot. And then also, while all of you are here, I wanted to do a little PSA. So this is an event coming up this Saturday. It's at 10 a.m. Swimming with Sharks book meetup. And this is part of the National Endowment for the Arts Big Read program. And so this is targeted to children and families. So if you have either an interest in sharks or any children in your life that are also interested in sharks, we'll be talking about the scientist Eugenie Clark this Saturday, and I believe we just dropped the link in that to register. So definitely check that out.
At the end of tonight's program, we'll be dropping a link in the chat to take a short survey about how things went tonight and give you an opportunity to provide feedback. We just like to give you a heads up that you'll be getting that survey in the chat and to your email if you registered through Zoom, and we really appreciate you taking the time to give us your feedback. So thank you in advance for doing that. All right. Well, if you've joined us before, you know that you get to interact with our presentation, and you can do that through the program called Mentimeter. So in another tab on your computer or through your mobile device, simply go to www.menti.com and enter the following code. And that code is 759310-2. Again, that's www.menti.com, and the code is 759310-2. Now, I'll give you a couple seconds to get that loaded, but if you're not quite caught up, the good news is that it's going to be at the top of the screen anytime we have a quiz question. So you'll be able to see it there. And Elise has actually placed it in the chat for us as well. Now, to get us warmed up, we actually have a practice question. So let's see if we can use Mentimeter and test our knowledge about plants.
Hi, everyone. So I'm back to do a fun little game with all of you. So just to make sure that everybody's used to using Menti, I thought this game about plants and seeds would be a great start before we start talking about mangroves. So looking at this picture, at these kind of creepy looking seeds, can anyone guess what kind of plants these might produce? And I believe there's three options there. So is it a hibiscus, a pitcher plant, or a snapdragon? So I'll wait to see, give everybody like a few seconds to try to put their guesses in before we go on to the next question. And then I'm gonna give you one more chance to try to guess a seed to plant matching game. Looks like most of you are saying snapdragon, couple pitcher plants. Somebody thinks it may be a hibiscus. All right. Looks like we have about 12 votes in, and oh, got a few more. And for those of you that are guessing snapdragon, you are correct. That is what those creepy looking seeds are. And then we'll play one more time for those of you that are still trying to get your Menti up and running to make sure you have a chance to practice. So what do we think? This one you may have seen in your own yards, more likely. But any chance anyone knows what type of plant that these seeds might produce? You got those bright red colors on a husky type thing. Do we think it's a magnolia, a pomegranate, or a holly bush? I don't know. Those red seeds might be tricky. You guys are quick to answer this one. Maybe you weren't so sure with the snapdragons, but looks like we got some magnolia fans in the crowd. All right. Yep, you guys are right. It is a magnolia. So maybe moving into our Science on Tap program, you might not already know the things we're here to tell you about mangroves.
All right. Well, thank you, everyone. And again, if you didn't get a chance to log in and play along, the code will be up every time we have a quiz question. So just keep your mobile device or your other tab handy. With that, I want to go ahead and introduce tonight's speaker. Julie Walker is a PhD candidate with the School of Natural Resources and Environment at the University of Florida. She is originally from Maryland, where she developed a love of marine ecology on the banks of the Chesapeake Bay. Following her undergraduate education at St. Mary's College of Maryland, Julie headed to a more tropical climate in Florida, where her current research interests include studying the impact of climate-induced range expansion of tropical mangrove trees into temperate wetlands. In the future, Julie hopes to continue to get muddy in the name of science while championing the importance of coastal habitats to anyone who will listen. And tonight, we're really lucky that we're going to get to listen to that. So with that, I'll turn it over to our speaker. Take it away, Julie.
All right, bear with me while I screen share. All right. Well, thank you all for listening to me today, and I'm very excited to talk to you all about mangroves and the tropicalization of coastal wetlands. But first, I want to tell you a little bit about myself. I grew up in a small town in St. Mary's County in Maryland, and that's near the Chesapeake Bay. And being so close to the bay, the water is a big part of the local culture. So much so that our town hosts the National U.S. Oyster Shucking Competition at our annual Oyster Festival, which is presided over by our Oyster King. And because of that, I grew up spending a lot of time outside and developed an appreciation for nature and coastal ecosystems, which inspired me to pursue a career in marine sciences. That and a deep-rooted desire to become best friends with an otter and to unironically sign off emails with tanks and best fishes. So fast forward today, where I'm currently working towards those goals as a PhD student at the University of Florida, where I study the tropicalization of coastal wetlands. And I spend a lot of my time looking like this. So today I hope to share with you a little bit about my work, and I hope you come away with learning a little something about your local coastal wetlands, how they're changing with the climate, why this may matter, and how you can help. So to start things out, what are coastal wetlands? Well, coastal wetlands occupy the intertidal zone, and this is the area that is submerged during high tide and exposed during low tide. And typically, the intertidal zone is covered with plants. Then these plants are specially adapted to tolerate this periodic flooding. In tropical regions, these are typically made up by mangrove trees, and temperate regions, it's typically salt marsh grasses. However, wetlands are going through this process of tropicalization, which is the poleward movement of species in response to a changing climate. And this trend is not limited to wetlands, but can be seen in many species and is happening at an even faster rate in marine species. And this is because of the great connectivity of our global oceans. And this can obviously lead to ecological problems. One example being with the invasive lionfish, which became invasive in the tropics, but now because of the changing climate and tropicalization, it has actually moved up towards the Carolinas and even beyond. Tropicalization is causing this movement of tropical mangroves towards the poles, and subsequently they are replacing temperate salt marsh habitats. And this is a pattern that can be seen in multiple regions across the globe, and the primary driver of this is decreased winter freeze events. Mangrove seeds or propagules are buoyant. You might have seen these in the water or washed up on the beach. And because of this, they disperse using the oceans and currents. And this allows them to spread quickly, like the lionfish and other marine species. And they are also transported even further when they're picked up by hurricanes, which may increase their range even more as large storms become more common with climate change. These factors have resulted in the formation of these transitional areas here in Florida on both the Atlantic and the Gulf coasts, with mixed mangrove salt marsh coastlines forming in Cedar Key and in St. Augustine. And if you focus in on the Atlantic coast of the United States, most of the northern coastline is dominated by salt marsh grass, with the most common species being smooth cordgrass. And whereas in South Florida, most of the coastline is mangrove dominated, and you can find both red mangrove, which is kind of the iconic tropical mangrove with the elaborate prop root system, which some people refer to as walking roots, and black mangroves, which has roots or pneumatophores that kind of look like pencils that stick out of the ground. And in the middle, in this transition area, or as we call it, ecotone. So if I say ecotone later in the presentation, this is what I'm talking about. You can find all three of these vegetation types with slightly lower densities of your red mangrove, just because they're a little more sensitive to these cold temperatures than black mangroves are. However, it is important to note that this is not the first time that mangroves have been in North Florida. And this is because mangroves are less responsive to change in average climate, but are more responsive to these rare freeze events. So they go through these periods of range expansion and then contraction when these freeze events happen. And some of you might recognize this as Fort Matanzas and St. Augustine. And these white arrows here are pointing out mangroves. And you can tell from these pictures that there's been a long history of mangroves moving in and out of this area. However, if the current climate trends continue, it's likely that this will be a more permanent change, with even conservative models showing that mangroves are going to move outside of their historical limit and into novel ranges, as even mild freeze events become increasingly rare. And with this map here, you can tell that even under the most severe climate models, you'll have mangroves moving most of the way up the coast, all the way into the Carolinas. So what does this really mean for our coastlines? Since mangroves and salt marshes are a little different, salt marsh vegetation is primarily dominated by grasses, whereas mangroves are these woody trees. However, they do have a lot of similarities. So to kick things off, we're going to take a second and brainstorm on what some of these similarities might be. This is our first Mentimeter question. We're going to take a couple seconds. I think someone got excited by our warm-up question.
Julie, I'm not sure if our responses are posting in, so maybe you can refresh the screen.
All right. Oh, yep, I can see them on the website.
There they are. We got them.
There you go.
Lots of ideas here.
All right, so it looks like we have lots of things going on here, and these are all really great answers. And so when you look at these answers, they can kind of be lumped into two different categories. The first being ecosystem services, and these are benefits that humans derive from the ecosystem. And I think someone said sequestering carbon, so CO2, taking CO2 out of the atmosphere. So that would be an example of a benefit that us as humans value from the environment. And the other category would be our habitat values. And these are values that the environment gives to other species. So someone posted nursery. So providing a nursery habitat for other species is an example of a habitat value. And although both mangroves and salt marshes have been championed as providing a wide range of ecosystem services and habitats for many different species, with their current expansion, it's still important to compare these attributes against each other. And perhaps because humans are a little bit egocentric and the primary focus of mangrove range expansion has really been focused on comparing these ecosystem services. So to start off, I'm going to give you all a little overview of some of these ecosystem services and their related studies. So the first service I'm going to talk about is carbon sequestration, which is the process of removing carbon from the atmosphere. And many of you probably already know this, but this process starts with photosynthesis, which is where carbon dioxide is removed from the atmosphere and taken up by plants to use to grow tissues and leaves and shoots. This carbon is then transferred from the plant back into the soil when the plant dies, and sometimes this process is referred to as litter fall. And usually at this point, this is where carbon will be released back into the atmosphere through the process of decomposition. However, in wetlands, the soils are frequently inundated with water, and this creates a low oxygen environment. And this greatly increases the amount of time that it takes for this plant litter to decompose and really reduces the amount of carbon that is released back into the atmosphere. And this results in wetland soils being comprised of a lot of partially decayed plant material called peat soil, which is what this picture here on the right shows. And this is why wetlands in general remove large amounts of carbon from the atmosphere, even greater than tropical rainforests. And since this is such an important process in regulating atmospheric carbon, knowing how mangrove migration might affect this process is very important. So knowing what we do about carbon sequestration, do you think that mangroves or salt marshes would sequester more carbon? Let's see if this one works for us. There we go. All right, looks like we're getting some votes. Give a couple more seconds. All right, it looks like most people said mangroves. And this study here looked at this exact question, and you guys were right. They found that mature mangrove stands, when compared to the transitional or ecotone or purely salt marsh environments, stored the most carbon. And this is primarily because they are larger trees and they use more carbon to create their trunks and leaves, which is what's called above ground biomass, or this green section here. So because they're building up these larger structures and are building these taller statured trees, they're storing more carbon than these kind of shorter statured grasses. So a similar ecosystem service is elevation gains. So mangroves and salt marsh grasses have complex roots and stem structures. And these roots and stems kind of act as a filter, and they can trap plant litter and sediments that are transported by rivers or upstream sources. And this trapping, as well as the decreased rate of decomposition that we talked about before, leads to the building up of this peat soil and increases coastal elevation. And this is a very important process as climate change is causing our sea levels to rise. These elevation gains can really help our coastal wetlands, our coastlines really keep pace. So again, we're gonna brainstorm between the two, mangroves and salt marshes. Which do you think is better at trapping sediments to build up elevation? All right, we're feeling some love for mangroves. Give a few more seconds. All right. Well, this study here did a comparison as well, looking at the elevation gains between both mangrove and salt marshes within current ambient temperatures. So that's our climate today is in blue, and simulated warmed environments. So what we're going to see in the future is in red. And what they found was that in future conditions, mangroves can actually build up this elevation quicker than future salt marshes. Whereas in current climate, they're kind of very similar. And this is probably because as these temperatures warm, mangroves can grow to be even larger and more mature, and they can create more of these complex roots that can potentially increase sediment and litter trapping even greater than our salt marshes. So good job, guys, 2 for 2. So our last ecosystem service is erosion control. And so these root structures that we talked about before are also important for erosion. And during storm events, such as hurricanes, this increased wave energy can start to erode the coastline. But root systems of these wetland plants can help to secure sediment and reduce this risk. So with everything we've learned about mangroves and salt marshes so far, which do you think would be better at preventing erosion? I'll give a few more seconds. All right, looks like most people said mangroves again. And you'd be right. This study here looked at different plots with different percentages of mangrove cover. So at this ecotone area where you have both salt marsh and mangrove cover, plots with more mangroves were more resistant to the effects of hurricanes and eroded less of the coastline. And this could be because mature trees might have these deeper root systems than when looking at the salt marshes that are kind of these grasses that might have shallower roots. So all in all, right now, you might be thinking that mangroves don't sound all that bad, and you're not wrong. Some places such as Louisiana, which have been greatly affected by erosion and storm damage and sea level rise, are starting to actually plant mangroves in their salt marshes, effectively speeding up this mangrove expansion in an effort to really utilize these ecosystem services and to preserve their coastlines. However, as we mentioned before, ecosystem services are only part of the story. And there have been far fewer studies that have really focused on how these two vegetation types compare as these habitats for different species. And that's why much of my research focuses on the effect of mangrove expansion on coastal habitats and the ecosystem in general. So for this part, I'm going to walk you through some of these potential changes and some experiments that we have done to answer these questions. So one habitat attribute that might change with the introduction of mangroves is habitat structure. And habitat structure is basically anything that makes up the shape of the environment, that if you changed it would affect the way that an animal could use that habitat. So to better visualize this, imagine that you are this shark you see here in the red mangrove, and these different pictures here represent your perspective of these different vegetation types. And you can see that they all look a little bit different, and your ability to use these habitats may kind of differ based on different attributes, such as the density, height, or distance between these roots or stems. So we were obviously interested in seeing which of these aspects of habitat structure were actually changing. And to do this, we conducted a survey of the vegetation across the ecotone in St. Augustine, where we measured several different structural attributes of black mangrove roots and cordgrass blades. We did not survey red mangroves just because there are not a large enough number of red mangroves in our study area in St. Augustine quite yet, although there probably will be in the near future. So at each of these sites, we measured stem height, stem density, and distance between our stems, or interstem distance. And what we found is that when you measure these different parameters, you find that black mangroves and cordgrass have very different structures, with cordgrass blades typically being taller and having a greater distance between their stems, being more spread out, whereas black mangrove structures are much shorter and densely packed. So now that we know that mangroves are changing this vegetation structure, we wanted to see how this was affecting species that use these systems as habitats. So this led us to our next question, which is how the introduction of mangroves is going to affect predator-prey relationships. So we're going to go back to imagining that we're all these predator sharks again, and think about how changing the habitat structure might affect you. So we have several different options to think about how changing structure might affect you as a shark, whether it's your ability to swim through the habitat, your swimming speed, your ability to see your prey, or all of the above. Give a couple more seconds. Looks like people feel like they know the answer to this one. All right, yeah, you guys are right. Changing the habitat structure can affect all of these things for predators. So as a predator, you might rely on swimming quickly through the habitat and using visual cues to catch your prey. And changing any of these structural attributes might decrease the amount of food you're able to eat. And this would have a greater effect on ecosystems where predators control the rest of the food chain. For example, if you look at some temperate salt marsh food webs like this one here, there are these large predators at top, which eat these smaller grazers here, such as the periwinkle snail. And in turn, these grazers can eat the salt marsh grass. And previous studies have shown that if you reduce these predators' ability to eat these grazers, these periwinkle snails, their population can actually increase to a size that is able to kind of eat down the entire salt marsh vegetation. And this would obviously affect many other species that utilize this salt marsh habitat. So to see if these predators were controlling the food web at the ecotone, we set up a 2-year-long experiment within both a mangrove-dominated creek and a salt marsh-dominated creek in St. Augustine. And we caged off different sections of the coastline to exclude large predators. And within these exclusion cages and control plots of the same size, we seasonally monitored them for multiple factors that could be influenced by predation control, including vegetation height and density, algal biomass, and densities of a subset of invertebrates, including periwinkles, oysters, mussels, and crab burrows. And from this experiment, we found that the exclusion of these predators didn't have an effect on any of these factors in either the mangrove or the salt marsh sites. And this meant that there's really no evidence that these large predators were controlling the ecosystem, like what we saw in these more temperate salt marshes. However, we still wanted to know if predators were being affected by this, even if they weren't controlling the food web. So to see if it was affecting predators' ability to feed in general, we measured relative predation rates using tethered dried squid or squid pops. And we placed them in the vegetation, you can kind of see sticking out right here. And we recorded whether it was eaten after 24 hours. And what we found was there was no difference in the predation rates between the squid pops that were placed in the mangrove or in the salt marsh habitats. And this showed that in general, predators were able to feed equally as effectively in both habitats. So this led us to our last question, was in general, how would mangrove migration affect the composition of the community in general? And this is because even if species are not being affected by predation, they might still be influenced by decreased food resources provided by mangroves in comparison to salt marsh grasses. And this is because mangroves are typically not as easy for many species to digest, which could make them a less desirable food source. And mangroves may also have a different or slower decomposition rate, which might result in less nutrients for the production of benthic algae that is a secondary food resource or a resource that a lot of coastal species also feed on. And this could result in different communities of species within these two habitats. So to do this, we did another survey where we looked at multiple community members across the ecotone, including different types of algae, including cyanobacteria, green algae, and diatoms. And what we found was that the only algae group that differed between the vegetation types was actually diatoms, which were higher in the salt marsh than in the mangrove habitat. However, what was interesting is if you look at all of the algae groups at the ecotone, they were all very low in comparison to measurements that you looked at in a temperate salt marsh. So it's not clear whether this was a very ecologically significant finding. We also surveyed our invertebrate community members across the ecotone, looking at the same critters that we looked at before, our periwinkle snails, oysters, mussels, and crab burrows. And we found that the periwinkle snail was the only invertebrate group that differed between the two habitat types, being higher again in the salt marsh. Yet, interestingly enough, we found again that counts of periwinkle snails were very low in both the mangrove and the salt marsh habitats at the ecotone, only ranging an average of 0 to 6 snails per meter squared, which is really significantly less than surveys in temperate salt marshes, where they can reach to densities of 200 to 800 snails per meter squared. So what exactly does this all mean? So overall, we found that mangrove migration is going to change the physical structure of the habitat, but that these changes are having relatively few influences on predation, invertebrate communities, or algal biomass. But it's very important to remember that this study is just a snapshot in time, and that these results might not hold true as mangroves migrate into these novel ranges that they haven't been before, where they might have a different densities of algae, of periwinkle snails, or completely different community members that we didn't even look at. As well as these results might not hold true as our current ecotone transitions to be fully mangrove. However, hopefully from my talk today, you've concluded that even though mangroves and salt marshes are different in some ways, they both have value as a habitat for other organisms and both provide ecosystem services for humans. But unfortunately, humans don't always treat them as if they're valuable, with salt marshes and mangroves being threatened across the globe by coastal development. Large-scale removal of mangroves are being done to convert them to aquaculture ponds like this one you see here, as well as sea level rise, which continues to threaten to drown both mangroves and salt marshes in the future. So to bring home this point, I have one more activity for you guys, and I want you to rank these ecosystems in the order in which you think they're being lost. Hopefully we didn't freeze again. Oh, there we go. Give a few more seconds for any last minute answers. All right, it looks like you guys said coral reef, tropical rainforest, mangroves, and then salt marshes. So the answer is mangroves and salt marshes are being lost at an annual rate somewhere in between coral reefs and tropical rainforests, with coral reefs being the highest and tropical rainforests being the lowest. And for me, this was kind of surprising because even though we're losing mangroves and salt marshes on the same scale globally as these other valuable habitats, there's a little less public awareness. Coastal wetlands in general are not getting Netflix documentaries or weeks of appreciation or these benefit concerts that other ecosystems are. But there are things that you can do on the individual level to kind of help these coastal systems, such as using a consumer guide, such as a Seafood Watch, to make sure your seafood is wetland friendly. Here in Florida, you can continue to educate yourself on coastal wetlands through the Florida Naturalist Program, or you can even volunteer with UF or other groups doing wetland restoration projects where you can help to plant wetland vegetation. And if you're a boater, you can make sure that you watch your speed and avoid grounding on oyster seagrass beds that help protect mangroves and salt marshes from harmful wakes. And with that, that's all I have for you today. But if you're interested in learning more, you can check out this paper that has a lot of the studies that I talked about, or feel free to shoot me an email. But if there's more time, I would be happy to take any questions now.
Wonderful. Thank you, Julie. Just as a reminder, you can drop questions at any point in the chat and we'll do our best to get to all of them. So I'll go ahead and start us off with one of our first questions, which was, have you looked at what kind of changes are taking place in the Indian River Lagoon in Brevard County?
So I believe if we look at the map that Brevard County has mangroves because it's a little farther south than St. Augustine, which is where I'm looking at. But I think I haven't really spent much time there myself, but I'm sure there's a mix of black mangroves and red mangroves. And as I mentioned before, red mangroves are a little more sensitive to those colder temperatures. So I would likely suspect that red mangroves would be kind of increasing in abundance as these freeze events and these cooler temperatures become increasingly rare and our climate warms. But I personally haven't looked at Brevard County specifically, but that would be something interesting to look at.
Thanks, Julie. This is another question about location. Do you have any ideas or predictions when mangroves might start to reach Georgia and northern Florida?
Yeah, so I think Actually, there are mangroves in Jacksonville. I have done some work out in Jacksonville, and there's not large stands, but there's definitely kind of individual trees kind of peppering the salt marshes there. And I believe that the northernmost mangrove is actually across the Florida-Georgia line right now. So they're already starting to make their way into Georgia, which is kind of novel territory for them.
Wow, thank you. It'll be interesting to see how that changes. What about birds nesting in salt marshes versus mangroves, and how might that be changing?
Yeah, that's one really interesting thing that I didn't look at, but I think would be interesting to look at. Specifically, there has been some studies in, I believe, Australia, which is another place where you can see this migration of mangroves, that have shown that birds that are ground nesters, so that they nest on the ground in the salt marsh and kind of use the salt marsh as a way to hide from their predators, they won't use those sites anymore if mangroves start to move into them. So once they lose those sight lines due to mangroves, they completely abandon these nesting sites, which is an interesting effect to look at for sure. And birds are definitely a very important species to think about when planning these studies, since they kind of have these long migration patterns. So if you break up some of their historical nesting sites, that could have wider spread problems on a larger range of locations for sure.
Good to know. This question, Julie, is more about your research and your experiments. So do you have an idea of whether it's the same species of predators feeding on the squid pops in both habitat types? And with your exclusion experiments, what was the largest species that could get through the fence?
So for the first part, I originally had planned to try and catch fish that were using the environment during high tide. So I had actually created these large nets that I would lower at low tide, and I would come back at high tide and kind of raise them. So I was supposed to catch these fish and funnel them into this net. So when they were trying to leave the marsh after feeding at high tide, I would catch them. So I could kind of see if there was a difference in predators that were using the salt marsh versus the mangroves. But what I found out was that I'm a very bad fisherwoman. And I spent the entire summer and caught one fish. So I had to quickly abandon that, or I would never graduate. But that is definitely something I'm very interested to see, if there is a different species that are utilizing these different habitats. And if someone who is better at catching fish than myself would like to volunteer to help me, I would definitely be interested in answering that question. And as for the largest size predators that could get through my exclusion cages, they were about, I'm say they were 2 centimeters in diameter, mesh netting. So it was excluding many large predators, but not kind of medium-sized predators. So still those smaller mud crabs could get through, and maybe like medium-sized minnows could get through, but your larger fish or larger crabs could not get through.
So I think we have a good follow-up question to that, which is, are there camera traps that would allow you to capture images of the predators?
Yeah, so that was also something that I think would be fun to toy around with. A lot of the creeks that I was studying were very muddy, so there was a lot of turbidity and it would be kind of hard to see. But I think it would be interesting to try and see if you could decipher, if you could identify any fish that were moving in or out. And I know that's a method that's used by a lot of people in more tropical environments where you have better visibility. And which is definitely something that I would be interested in trying at some point.
And while we're talking about more tropical areas, do you have any idea about how the mangroves might be changing in the Florida Keys, in that area of Florida?
Yeah, so in the Keys, I think one of the largest effects that they're going to feel from climate change is increased storm events. So I'm sure if people who live in the Keys or visited have seen kind of a lot of dead mangroves from past storms. And what's kind of causing that is when a large hurricane comes through, it can kind of rip off all the leaves of these mangroves, and particularly red mangroves, which are the more common in tropical environments such as the Keys, have a hard time recovering from that. So if these repeated storm events come in close succession, these mangroves are going to have a harder and harder time bouncing back. So that's kind of what one of their biggest threats are going to be in the Keys.
Well, speaking of kind of impacts of climate change, you talked about how mangroves might help keep pace with sea level rise, but that also sea level rise might drown them out. So tell us a little bit more about that and kind of where that balance is.
So that's where you kind of get regionally specific. So that comes into play with how much sediment that they're receiving. So as I said before, mangroves and salt marshes kind of act as filters. So they can build up this elevation in part because of their litter fall and some of the plant material that's generated by themselves, but also by catching some sediment that comes off the environment. And too much sediment is a bad thing because it can clog up the kind of air holes in the root system, but they need some sediment to keep pace. So if there's upland divergence, such as like damming or diverting water, like we do a lot in Florida, you can kind of change the amount of sediment that is coming to these systems. And if they're not getting enough sediment, they can't build up the elevation, which can kind of make them at risk for not being able to keep pace with sea level rise. And then in general, there's only so fast that they can build, even if they have a good sediment supply. So if kind of our moderate range projections for sea level rise are still could be enough to outpace what mangroves are capable of keeping up with.
Thanks, Julie. And here's another question that just kind of refers back to something I think you mentioned earlier, but just to remind us, are the northernmost mangroves, those are the black mangroves, is that correct?
Yeah.
And then how far north are the red mangroves?
The red mangroves, they're in St. Augustine now, and they're definitely over the 4 years that I've been here and studying them have definitely grown in their presence. So about 4 years ago, when I first started doing this research, it was only common to see maybe one or two kind of periodically throughout the area of St. Augustine, but nowadays you can definitely see small patches where you can see stands are forming. So it's definitely something that you can see ecologically happening on a very short time scale. And I'm not sure where the northernmost one is. Assuming that there's probably a few that are north of St. Augustine by this point.
Thanks. We've had a couple of comments about people really liking mangroves because they attract certain types of fish that I think they like to catch. Could you talk a little bit about how fisheries might change between salt marsh and mangrove habitats?
Yeah, so that's another area that probably could use more research. Like I said, that the habitat connection between mangroves is very strong and they do support a large fisheries, but I don't know how much has been done to compare salt marsh versus mangrove and how much it's actually going to be the mangroves driving changes in fisheries, or if independently these tropical fish are also going to be moving northward with climate change as well. So I think that's definitely an area of study to see if mangroves are kind of facilitating this movement of these more tropical fish or these more maybe more attractive commercial fishes that recreational or fisheries might be interested in, is definitely an area where research could continue and would be an interesting thing to study. I know particularly snook is one that people are interested in looking at, and that has, especially on the Nature Coast in Cedar Key, they've been seeing a lot more of lately, and a lot of anglers enjoy catching. And I think that would definitely be one to look at to see if maybe there is a connection between mangroves, and definitely a good area to keep researching for sure.
Yeah, we did have one comment come through the chat from someone mentioning their love of mangroves for the snook. So I'm glad you gave them a shout out, whether you knew it or not. And then our next question is, how does change in salinity impact mangroves and cordgrass?
So I'm not completely sure about, well, both mangroves and salt marshes are pretty tolerant of higher salinities, but where you get kind of an issue is if the climate changes and areas get less precipitation, it is possible for the evaporation to be too great and to create really hypersaline conditions. So there is an upper limit. And what happens then is that you can either get more, instead of your cordgrass, which is kind of the grassy looking salt marsh grasses that I've shown throughout here, you can get more of a succulent looking grass, which you can see in some of the higher marsh areas in St. Augustine and in Cedar Key and other areas that kind of look like typical succulents, which are a little more salt tolerant, or at the even more extreme end, where it's even saltier than that, they can be converted to salt flats. So you lose all vegetation and it becomes more of a muddy kind of salty area that doesn't support any vegetation, which obviously is not as valuable as a habitat for some of the creatures that we're more used to seeing.
Great, thank you. And I think we're getting close to time. So if you don't get a question answered today, I'm sure you can reach out to Julie and she would love to chat some more. But we can answer one last question on maybe what people can do to get involved. So do any of the UF wetland restorations projects take volunteers?
Yeah, so you can definitely check out the UF Wetlands Club. So they do a lot of volunteer events, and I think you can find them on Facebook, and also the UF Nature Biological Station. They do particularly a lot of living shorelines restoration. So they do a lot of planting events, which you can definitely check out. And then I would just check with your local environmental groups if you're not in either of those areas, and keep up to date, especially if you're on the coast. There's a lot of restoration efforts going on out there.
Awesome. Thank you so much, Julie. I think you inspired all of us to put on our mud boots and really get out there.
That's what I strive to do.
Awesome. Well, thank you so much. You did a great job tonight, and I'm sure our audience agrees. And I'm sure we'll have some follow-up questions and people keeping in touch with you as well. So thank you everyone for attending and following us as we mangrove on the move to this to a new date tonight. And we'll see you again later. Oh, and we did just repost that survey link. So you can either click the link for us right there in the chat, or it'll also come to your email inbox as well if you missed that. Any final words, Sadie or Julie?
Just wanted to thank Julie for a great presentation, and thank you everyone for watching, and have a wonderful evening.